All right, in this video, I'm going to be wrapping up the radicals notes here with these examples. I'll fit it in under the title Example 3. In these examples, we are supposed to rewrite these into simplified radical form. So our answer should end up with a radical in it unless we can simplify or evaluate it just a little bit further than that. So just to quickly refresh, remember we're thinking power over root when it comes to our radicals and our rational exponents. So if I look at this rational exponent, this is going to be my power, this is going to be the root. So I'm going to rewrite this as the fourth root of y to the first, but I don't have to write that 1 on there since it's just implied to be there. So that's as simplified as I can get that. Similarly here, I'll write this as the fifth root of 32. Again, I don't need that exponent of 1. This one, however, I can further simplify since I have a numerical value underneath here. So I could think this through and think, okay, what number could I multiply 5 times by itself in order to get back to 32? And that happens to be 2. 2 times 2 times 2 times 2 times 2 does indeed get me to 32. But if I'm having trouble coming up with that, in my calculator, you also have the ability, if you hit the math button, option 5 allows you to input any type of root that you want, but you will have to type that type of root either before it or in a newer calculator. It comes up with a little index for you to fill in that problem. So you could type in your fifth root of 32 there, or like that, and either way I do it, I get to 2. So that would be the most simplified and evaluated version there. Example 3, if you want to go ahead and try that, you can pause this video for just a moment. Well, that one would be the fifth root of x to the third. All right. Moving on to a few more complicated examples here. If I look at this one, they all share the same denominator, meaning they all have the same root. They just have different powers here. So the way this one will work is I will set up a much larger radical, all with the same root of 5, and then each of these variables will get a different exponent, n to the fourth, n to the first, p to the second. And then obviously to simplify it just all the way, I can drop that n to the first. I don't have to have that exponent of 1. So that would be as far simplified as we can get that one. All right, letter E actually draws back from our exponents examples and our exponent rules. Since I have the same base, I can subtract our exponent. So I can think 5/6 minus 1/3. Now I could throw that in my calculator, or I could think, what can I convert this to so that it has the same denominator as my other fraction, or so that I have common denominators? Well, if I multiplied both top and bottom by 2, I could get to a denominator of 6. So I could think of this as 5/6 times 2/6, which would get me 3/6. So that would be m to the 3/6. Well, that, of course, can be simplified down to n to the 1/2, which can then be rewritten as simplified radical form, the square root of m. And again, I'm leaving off the 2 since it's implied to be a square root, and I'm leaving off the 1 since that's implied to be the power there. This one started in radical form, but I want to see if I can simplify it. So I'm going to kind of do a little sneaky trick here to put it back into rational exponent form, a to the 2/4 power, and then reduce that fraction, turning that into a to the 1/2. Which I can then change back to the square root of a. Once again, invisible 2, invisible 1. Last but not least, one more example that's going to draw from our exponents knowledge. I'm going to switch colors just so this one pops a little bit here. I'm going to apply this exponent of 1/3 to both of the factors within my parentheses here. So this would be r to the 9 times 1/3, which just comes out to be 9/3, which would just be 3. And then 2 times 1/3 would just be 2/3. And then I've got t to the 2/3. Now this, I'm not going to simplify any further. R to the third power is as simplified as it can get. But this portion, since I still have a denominator, that means I still have a root, which I can then put in radical form. They both have the same denominator, so similar to this one, I'm going to rewrite a radical with a root of 3, or an index of 3, and then s squared and t squared. Each would have that power of 2. And bring our cubes down, and it's as if this has been simplified out, and these are the only ones left in. All right, at this point, you should be able to attempt worksheet 3 with all your rational exponent knowledge.